Hi, this is Pooja Kumar from Loyola Institute of Technology, and now I'm going to present here about a distributed database management system. A distributed database is a database that runs and stores the data across multiple computers. That means the data are stored in a different locations of the computer. And now we are going to see the agenda of this presentation. And first of all, we see the introduction of this topic. About this topic, in the era of big data and the cloud computing, distributed database and systems have gained prominence due to their ability to store and process vast amount of data. Yeah, it stores a vast amount of data in a decentralized. What is mean by a decentralized? Decentralized is a access that allow different communities to access that network or a computer is called decentralized, and these systems consist of a multiple nodes located in a different location. That is why we are calling this database called a distributed database system. And replication process, replication process is nothing but it is maintaining the multiple copies of the same data on a different nodes, availability and the system reliability. However, these are the all nodes poses a significant challenges. And now we are going to see the problem statement. What is mean by problem statement and why we are going to see that? Problem statement is what is the problems are done and why, what is the solution we need to the problem statement. First of all, the main challenge in the distributed database and the system is to maintain the data consistency. Yes, the main reason of the problem statement is maintain the data consistency. Consistency means if the data containing or not containing the errors in that database. Okay, and the consistency ensuring the nodes have a synchronized view of a database. If the database having the inconsistency means it lead to the data loss. That is called the inconsistencies can lead to the data loss, corruption and inaccurate results. Yeah, if we have the database in the error data in the database, of course we have to the result of an incorrect inaccurate results. Therefore, there is a need for consistency model and algorithms that can guarantee data integrity in the presence of replication. Well, first of all, investigation and understanding the various consistency model. Yes, first we know what is the process that we can understand the consistency model. What are the consistency model? Like weak consistency, eventual consistency, casual consistency. There are different types of consistency model. No, we have to understanding the various consistency model and then evaluating existing algorithm for enforcing the consistency model. Already the authors or database procedures architectures are already give the algorithms to the evaluating the consistency model like two-phase protocol and two-phase commit, paxos and draft, distributed locking, shared lock, exclusive lock and blah blah blah. There are so many algorithms or previously we have existing algorithms for enforcing the consistency model, and then assigning the impact of consistency model and algorithms on the system performance. Yeah, we know what are the database need, what are the algorithms. We have to separate and we have to solution for that problems to the problem statement. And research objective. Research objective is the aim to address the challenge of maintaining data consistency in the distributed database system. That are the investing and understanding the various consistency model, evaluating existing algorithm for the enforcing, and already we said that assigning the impact of consistency model algorithm on the system performance. And then we are going to see about understanding the consistency. First of all, we are going to overview the database, distributed database. What is mean by a distributed database system is a collection of multiple interconnected database. Yeah, it's a geographically distributed across a different locations or a nodes. Yeah, it's correct. Okay, and then the data distribution. What is mean by data distribution? We having a separate data which are across a multiple nodes to share the database. That is called a data distribution. And replication. Replication is a key. It is a key feature. Okay, it is a key feature of a distributed database system. It maintaining multiple copies of the different nodes, and then a distributed query processing. Of course, we having a database model means we have to query the process, and that is called the distributed query processing. And then consistency model. Consistency model is nothing but where update propagate gradually and some data at all times to eventual consistency. And these are the understanding of consistency before we know that what is meant by the distributed database system. And now we are going to understanding the consistency and different types of consistency model. What are the different types of consistency model? Strong consistency, weak consistency, eventual consistency, casual consistency, and read your writes. And we have also one type of consistency called monotonic consistency. First, what is mean by strong consistency? Strong consistency that ensure all nodes in a distributed system have consistent view of the data at all times. And then it have one extra advantage is called it will return the latest committed value. And weak consistency. Weak consistency relaxes the strictness of a strong consistency. Yeah, weak consistency means it is a strictness. Weak and strong, that is opposite words, that is called the strictness of a strong consistency by allowing temporary inconsistency between a nodes. Okay, and then it's providing a higher availability and the scalability. But the weak consistency sacrifice some data integrity, that is called a weak consistency. And eventual consistency. Eventual consistency is a weak form of a consistency. Comes from the weak consistency and guarantees no further updates are made to a data item. That is called as eventual consistency. Casual consistency. Casual consistency is a one operation. Casually it depends on the other. That is called a casual consistency, and it can read and modify the data. It is called a casual consistency. Read your write consistency. The name which consists read your write consistency. Once a client perform a write operations on the data and subsequently performs a read operation. Yeah, it's simultaneously it's done. The read operation will return the value returned by the client. It is called read your write consistency. Monotonic consistency. Monotonic consistency guarantees that if a client reads a particular value, and the value item is subsequent reads, that is called a monotonic consistency. And now we are going to see how consistency model impact data reliability and accuracy. Consistency models play a crucial role. Yeah, it's play a crucial role in ensuring a data reliability and acquiring in distributed database system. Now we are going to see how consistency model can impact data reliability and the accuracy. Data replication is the first and main consistency model that impact the data reliability. Data replication, already we know it is a multiple nodes in a distributed system. And the data integrity. What is mean by a data integrity? Consistency model define the rules for maintaining data integrity in a distributed system, and the operation appear to execute automatically and in a total order. It's called in data integrity. And then the third impact is a read operation. Consistency model impact how read operation observe the data updates. In a strong consistency model, it will done in the strong consistency model. Read operation always return the most recent committed value. It's a process of a strong consistency. We already know that. So that is the process ensuring data accuracy. Still, it reads can impact data accuracy, especially in the scenarios where immediate consistency is a crucial. That is called an read operations in the strong consistency model. And concurrency control. Yeah, we have already know in a database management system there are a concurrency control system. Yeah, concurrency control is done in the transaction process. So here also consistency model is an influence concurrency control mechanism in a distributed system. It also done in the strong consistency and strict synchronized mechanism. It is done in a strict synchronized mechanism. And these are the types of consistency and impact of the consistency models. And existing research. What are the existing research is done in the distributed database management system? First of all, strong consistency models such as linearability and serializability ensure that appears to acquire automatically and in a specific order. And we are already know that distributed locking database system, we are already know, I already told these types of these topics. And now we are going to pros and cons for the different approaches. We have so many approaches in the field of distributed database management system. Yeah, strong consistency model, weak consistency model, concurrence algorithm, multi-version concurrency control, conflict-free replicated data types, and we have so many approaches in the distributed database system. Now one by one we are going to see the pros and cons of these types of approaches. And the strong consistency having all operation appear automatically in the specific, and these are the pros and cons of the different types of approaches. And now we are going to see the challenge and limitations of the distributed database. Complexity, performance overhead, network communication. Consistency models and algorithms can complex. Complexity is means the algorithms of the distributed database systems are complex. And performance overhead. Strong consistency model that reinforce the strict synchronization and coordination between nodes can introduce performance overhead, that is called performance overhead, that done in the strong consistency model. Network communication. Distributed system rely on a network communication which introduce challenges such as latency, network failures and message delays. And these are the challenges and limitations done in the distributed database system. And other challenges that is done in the distributed database system is trade off with the cap theorem. Yeah, the main theorem that is in the distributed database system is a cap theorem, that is mean consistency, availability and the partition tolerance. These theorem having the impossible simultaneous achievement in the distributed database system, that is a trade off with a cap theorem. And then now we are going to see the recommendation and the solution. First of all, we having a problem means there is a definitely we have a solution for that problem, that is called a recommendation and a solution for the problem. First, understand the application requirements. First of all, we are going to see the problem and then we are going to see the solution. First, understand the application requirements. What is mean by the understand application requirements? We having a understanding of specific requirements of the application in terms of data consistency, availability and the performance. This understanding will guide the selection of appropriate consistency model and algorithm aligns with your application needs. Which type of algorithm is used for which type of needs is called an understanding application requirement. Evaluate trade-off. Evaluate trade-off is the trade-off between the consistency, availability and partition tolerance in the cap theorem. That is, we have to evaluate the performance and the scalability of the system is called an evaluate trade-off. Consistency model and the selection. Choose the most suitable consistency model based on the specific needs of your application. Like for the scenarios, for example, we take a scenario where eventually consistency is acceptable. Explore algorithm like Dynamo, CRT, conflict-free replicated data types or a casual consistency model. So we need to most suitable consistency model based on the specific needs of your application. And then optimistic concurrency control. Optimistic concurrency control technique that allows a balance between the consistency and the performance. For example, you can use a strong consistency with a local data center and a weaker consistency across geographically distributed data center. This is the hybrid approaches which is used in the solution of the distributed database system. And we have the error handling and the recovery. Error handling means if we have an inconsistency data means we have confirmed we having the inaccurate result. So implement the robust error handling and recovery mechanism to handle the network failure. And in the node crashes, in the scenarios of node crashes and the exponential scenarios, consider technique like automatic failover and etc. So many scenarios are giving the errors. So we have to error handling and recovery technique. And then we are going to see about evaluation of performance analysis. And then what is mean by the evaluation of performance analysis in the distribution database system is several factors that should be considered as a key aspects: throughput, latency, scalability, and resource utilization, consistency guarantees, workload patterns, and benchmarking. Yeah, benchmarking is a main thing in the evaluation of performance analysis. And then we are going to see the conclusion of the database distributed system. Yeah, of course. Nowadays, the challenges is implementing robust consistency model and algorithms. But in the conclusion, we have to conclude something. Yeah, of course, we have to conclude something in that distributed database system. First of all, what is the future research direction? Advanced consistency model. Now in the future we are using the advanced consistency model. While existing, the models are different trade-off between the consistency and availability of the database. And we are using the future of we don't know, we use the machine learning or AI also will handling the database in the distributed database system. So in today we have to future research in this area can focus on the address of the challenge associated with the data consistency in geo-replicated distributed system. Yeah, of course it is consistency in the geo-replicated distributed system. The unique challenge of geo-replication such as increased network latency and nuanced conflict resolution. So the objective, furthermore, the study aims to identify the recommendation of solution from the literature to overcome these constructs and their effects of the scalability and the availability. So these overall, these are the overall concluded. I think the research and development of the consistency model algorithm and best practices in distributed system are crucial for ensuring the integrity and the reliability of the data. In today's big data and the cloud computing world, we take the big data and the cloud computing world by addressing the challenges and limitation. Researchers and practitioners can continue to improve the performance and efficiency of distribution systems and enabling the successful implementation of large scale decentralized data process and stored solution. And thank you for giving me this beautiful opportunity, and thank you so much.